All right, let's get into it. The electric motor. I mean, it's this invisible force that's behind pretty much everything in our modern lives, right? From the little buzz in your phone to a massive subway train. But the story of how we got here, well, it's packed with surprises, brilliant minds, and even a design that's billions of years old.
So let me start by asking you a question. When you think of the very first electric motor, what pops into your head? Probably some clunky machine from the Victorian era, all brass and wires. Well, the real answer is a whole lot older, and I mean much, much smaller.
Believe it or not, this is it. The very first electric motor we know of is the propulsion system for microscopic bacteria. On the left here is a plastic model of it, and next to it, the diagram. And look, it's got a rotor, a stator, a bearing, all the key components just perfected by nature to spin a little tail and push the bacteria around. It is an absolute marvel of biological engineering.
Okay, so how did we go from nature's incredible little blueprint to our own inventions? Well, for us humans, the journey didn't start with the machine. It started with figuring out one of the fundamental rules of the universe. And this is the key. Back in 1831, Michael Faraday discovered that electricity and magnetism aren't really separate things. Nope, they're two sides of the same coin. He figured out that you could use one to create the other, and this is the crucial part, that when they interact, they can create physical force. They can create motion. That was the spark that lit the fuse for everything to come.
And this picture shows that core idea perfectly. See, when you run electricity through a coil of wire, poof, it creates a magnetic field, just like a regular old bar magnet. You've just built an electromagnet. And by cleverly turning these magnetic fields on and off, you can push and pull on other magnets and force them to spin around. And right there, that's your motor.
And once that principle was out in the open, boy, things started to move fast. By the middle of the 1800s, the first DC, that's direct current, motors started showing up, powered by some pretty crude batteries. But then, in the late 1800s, the whole game changed. You had Thomas Edison's team building practical DC machines for his new power grid, and at the same time, this visionary named Nikola Tesla patented a totally different idea, the AC, or alternating current motor.
And this right here set the stage for the legendary War of Currents. Edison, he was all in on DC power, where the electricity just flows steadily in one direction. Simple. But Tesla, he championed AC power, where the current flips its direction back and forth really fast. And that fundamental difference shaped everything about how their motors and their entire electrical systems were designed.
You can literally see their two competing visions right here. On the left, that's an early Edison DC machine, a total beast they nicknamed long-legged Marianne. And on the right, you've got an early AC motor based on Tesla's designs. Two totally different paths, but both were trying to do the same thing. Turn electricity into real useful work. And that competition, it just set the stage for a century of innovation.
So, after that initial big battle between AC and DC, the story didn't just end with one winner. Not at all. Instead, the basic idea of a motor, it just exploded. It branched out into this huge family tree of different specialized designs, each one tweaked for a different job.
For the first 75 years or so, a few key types really dominated the scene. You had your classic DC motors, sure, but also these new AC designs like the super reliable induction motor and the super precise synchronous motor. They even made some motors that were flexible enough to run on either AC or DC power. But then, in the last 50 years, the electronics revolution just changed the game all over again. You know, with microcontrollers and advanced electronics, a whole new generation of motors was born. We suddenly got these incredibly precise stepping motors, super efficient brushless motors, and the ability to control the speed of just about any motor with amazing accuracy.
But here's the thing. No matter how different they all look or how complex they get, they all come back to this one fundamental purpose. Every single one is a machine designed to do just one thing: take electrical energy and turn it into useful mechanical energy, to make something spin.
So, with that huge family tree in mind, let's zoom in on where we are today. Because out of all those different designs, a powerful trio of modern motors has really risen to the top. These are the ones at the heart of everything from giant factories to the electric car you might be driving. And here they are, the big three of the modern motor world: the AC induction motor, or IM, the reluctant synchronous motor, or RSM, and the permanent magnet synchronous motor, also known as the PMSM. Now, the names might sound a little complicated, but they actually share a surprising amount of DNA.
Now this is what I find so cool. They can all be built using the exact same stationary outer part. That's called the stator. So the same factories can make the basic shell for all three types. All of their unique personalities, what makes them different, it all comes down to the design of just one piece. The part that spins on the inside, the rotor.
So first up, you're looking at the rotor for the classic induction motor. This is the workhorse of industry. It's rugged, it's reliable. The way it works is the rotating magnetic field from the outside part induces a current in these rotor bars, creating another magnetic field. It's almost like it gets dragged along for the ride, just trying to catch up.
Okay, now look at this one. The shape is completely different, right? This is a reluctant synchronous motor's rotor. It doesn't have any windings or magnets. It's all about that special shape, which creates paths of least resistance for the magnetic field. So the rotor just naturally locks on and follows the stator's rotating field, perfectly in sync, kind of like how water will always find the easiest path downhill.
And finally, the PMSM rotor. This is the superstar. This is the design you're going to find in high-performance stuff, like electric vehicles. And just like the name says, it uses powerful permanent magnets that are built right into the rotor. This creates an incredibly strong magnetic field that interacts super efficiently with the stator, giving you a massive amount of torque and power.
So think about it, from a microscopic marvel of nature, to the epic rivalry between Edison and Tesla, all the way to the incredibly powerful and diverse motors we have today, this technology has been on one heck of a journey. It's an amazing story about how one simple principle, that dance between electricity and magnetism, grew into a technology that has completely reshaped our world. It really makes you wonder, what's it going to power next?